This is a video for Calculus AB for the couple of examples that we have not been able to get to in class. Thought I'd make this video for you as you maybe work through some of them and are working to get prepared for upcoming quizzes and later on tests. So this is from Unit 3, Day 7. We did not do, I believe we did not do number 3, just to give you some perspective here. I think in class we did these two. I think we did number 1 and number 2. So here is number 3. Okay, so this says find the intervals where the graph of h of x is increasing or decreasing if h prime is equal to that expression right there, and we're supposed to justify our answer. Okay, so the first thing I want to figure out, I want to be thinking about here is if I'm looking for where h is increasing or decreasing, I'm looking for where h prime is either positive or negative. And so in order to figure that out, it would be helpful to know where h prime is 0. So I'm going to set h prime equal to 0. And because h prime is in factored form, finding the zeros is pretty straightforward. So this would be at x equals -3, x equals +1, and x is equal to +4. I'll then make a little sign chart to help me get organized with those numbers on the sign chart. So -3 goes here, 1 goes there, and 4 goes there. I do recommend that you use multiplicity just for sake of speed, but you can always test each of the intervals. There are 4 intervals. There's a purple, there's a yellow, there's a blue, and there's a red. And so one way or the other, I'm going to test these intervals out, and these intervals are going to be for h prime. We're going to be testing out h prime within each of these intervals. So, like I said, I am going to use multiplicity, but no matter what I'm using, I'm going to have to at least test one interval. So I'll test this one right here, h prime of -4. That'd be a good test value. This would equal -1 times -5 squared times -8 cubed. And I am simply going to write down, or I'm going to express whether this is a positive or a negative number. Here's how I could think about this. This is negative. This will for sure be a positive number, and this will for sure be a negative number. So a negative times a positive times a negative is a positive. So I can say that for certain. So I'll say that the purple interval, h prime, is positive. And then I'm going to use multiplicity. Multiplicity is basically looking at the exponents on each one of these factors up here and determining whether the graph of h prime will indeed change signs at a 0 or will not. Will actually just bounce off of the x-axis. Okay, so the yellow interval happens right when we transition through -3, and -3 is generated by this purple factor. And since that purple factor has an odd multiplicity, in other words, the exponent is 1, it's an odd number, then we know that h prime will change sign at that -3. At 1, that comes from this factor, and you probably will notice that this factor has even multiplicity. Even multiplicity means that the graph of h prime will not change signs there at 1, and so h prime will remain negative in the blue interval. And then the multiplicity on the final factor is odd, and that means that the graph of h prime will change signs, so the red interval is positive. So how do we wrap this up and justify our answer? I will say this. H of x is increasing on these intervals from -infinity to -3 and 4 to infinity. Because h prime is positive, or at least non-negative, on those intervals. And then, in addition to that, I can say that h of x is decreasing on the interval from -3 to 4 because h prime of x is less than or equal to 0 on that same interval. So what I've got here is I've responded to the question. I've also justified my answer, the part of my statement where it says because, whatever comes next, that's my justification. Okay, so I hope that went well. We're going to do number 4 here. I would encourage you to do number 4 on your own and then perhaps watch the video and see how it all went. Okay, so number 4 asks us to sketch a graph. It tells us that f of 3 is equal to 2. So that's right here. And f of 6 is equal to 7. So that's a point, and that's just right up here. But, so what's coming up next is going to kind of contradict what we think might happen. But f prime is negative on the open interval from 3 to 6. And if all of these things are true, we're supposed to sketch a graph of f of x on that interval. So the hard part about this is when we see these points on the graph, we automatically think of this, don't we? Something where we're generally increasing from left to right. But then when we look at this, we see that f prime is negative on the open interval from 3 to 6. We start to feel a little uncomfortable because if f prime is negative, we know that f is decreasing. And so that would indicate that the graph would be doing this, but that doesn't seem to go with those points very well. The key to this is recognizing that f prime is indeed negative, but it's on the open interval from 3 to 6. So I'll give you an example of what the graph could look like. Open circle on 3. Let me try that again. Open circle on 3, steadily decreasing to 6, to x equals 6, and then another open circle there. This actually perfectly fits this situation because on the open interval, f is decreasing, and we have f prime being negative, so it perfectly fits. But then we're still able to have these 2 points here and here fulfill the actual values of the function that we were given. So I would say some graph that looks something like that would be appropriate there for number 4. Okay, we're going to skip ahead now to Unit 3, Day 8, and there were a couple of questions here we didn't do. We did do number 1, but we did not, I believe, do number 2. Yeah, we definitely did 4. So I believe it's numbers 2 and 3. Okay, so this is going to be a pretty similar question to one we did earlier. It's going to have a different meaning, but largely the process will feel similar. So this says determine the open intervals in which the graph of g is concave up or down. So when I see concave up or concave down and I see that we've got a g double prime, my first thought is I want to figure out where g double prime is either positive or negative. This will tell me where g is concave up or concave down. So I'm going to set g double prime equal to 0. The reason I'm going to do that is because if I know where g double prime is equal to 0, I'll be able to figure out pretty easily where g double prime is either positive or negative. And again, like before, because g double prime is factored, this is a pretty easy equation to solve. So g double prime will equal 0 at these 3 points right here. So make a little sign chart for g double prime. -2, 1, and 4. So just like before, I've created 4 different intervals. I'm not going to color code these here. I'm going to do a real similar process. I'm going to test out this interval right here. G double prime of -3 makes sense as far as the test value goes. This would equal -7 times -4 squared times -1 cubed. So I know that this will be negative. I know that this will be positive. I know that this will be negative. So that left interval, a negative times a positive times a negative, well, that's going to end up being a positive. So for this interval, I've got a positive value for g double prime. -2 is generated by a factor that has odd multiplicity, so we will get a sign change here. X equals 1 is generated by a factor that has even multiplicity, so no sign change. And then x equals 4 has odd multiplicity, so we will get a sign change there. Interestingly enough, the two sign charts here look the same, but they have very different meanings. The other sign chart we did a few minutes ago had to do with F prime or H prime or whatever it was, and this is G double prime. So they have a very different meaning, even though the graphic looks the same, or very similar at least. Okay, so now I'm going to wrap this up and justify my answer. So I'm going to say that G is concave up on the intervals from negative infinity to negative 2, and 4 to infinity, because G double prime is positive on those intervals. And then G is concave down on the interval from negative 2 to 4, because G double prime is negative on that interval. Okay, so we have number 3 next. Again, really strongly encourage you to try a question like number 3 by yourself. Use the video to kind of help you check and gain understanding if needed. Okay, so we have a graph of G prime down below. I want to recognize that for sure. We're supposed to determine the intervals in which the graph of G is concave down and increasing. So we want these two things to be happening at the exact same time. Okay, so when I see this concave down, my first thought is, knowing that I've got a graph of G prime, I'm going to be looking for where where G prime is decreasing. And when I see that G is supposed to be increasing, that's what I'm looking for. That tells me that I'm looking for where where G prime is positive. So I'm looking for a place where G prime is positive and decreasing. So here's how I like to do this. I'm going to highlight, and I'm going to say that because I'm looking for where G prime is increasing, where G prime is positive, I'm going to highlight the upper part of this. This will tell me all of the intervals, all the points where G prime is positive. This will tell me where G is increasing. And then I'm actually going to make this a little bit lighter. And then I'm also going to be wanting to bring in the other piece of the puzzle. I want to be looking for where G prime is decreasing because I want G to be concave down. So I'll highlight this in red. So G prime is decreasing here and here. And those are the places where our two shadings essentially overlap. So those are going to be the two intervals on which G is concave down and increasing. So to justify my answer, I'll say to answer and justify it, I will say G is concave down and increasing on the interval from negative 4 to negative 3 and from 1 to 3. Because G prime is positive and decreasing on those intervals. Okay, hope number 3 went well for you. Overall, I hope this video has been helpful. If it hasn't, or if it just brought up other questions for you, then feel free to contact me and we can discuss. Otherwise, I look forward to seeing you in class next time.